take a look at analyzing continuous and discrete functions, or discontinuous ones. Now, seem like really big words, but they're not that difficult. Continuous, you guys know what continuous means. It goes on and on. Discontinuous has a gap in it somewhere along the line. And discrete functions, discrete is simply just single pieces of information. Okay? Separate things. That's all it is. So if I take a look at this, these two here would be considered continuous functions. They're always going. Now, whenever we're looking at this, we want to take a look at how things are going from negative side of x to the positive side of x. From negative infinity to positive infinity is what we always have to consider. So going from left to right. So if I take a look at what I see on the graph here going from left to right, there are no gaps. The line just keeps on going. Now, when you look at this, you might sit there and think, hey, I don't see anything over here. I don't see anything over there. But the arrows on the end mean that it keeps on going. And it will slowly keep moving to the left and to the right as you go up. The larger your values for x that go into this, the bigger it becomes. We're only looking at it at a piece of it. You got to think of it as just a window. If you're looking out the window, you don't see the whole world. You see parts and pieces of it, but not the whole thing. Now, when we get over to the discontinuous functions, you'll notice that there's a bit of a dotted line going up and down here. There's a gap there. Something is happening. Generally, what happens is it's causing the denominator to go to a 0. Division by 0 is undefined. We can't have that. Now, another way that we have discontinuous functions is what we've got up here. And that's like a set of steps. How does that work? Well, it's kind of like, well, think of take a field trip, students on buses. Okay. If I've got a 72 passenger bus, can I put 69 students on there? Can I put 70? Can I put 71? Can I put 72? Yeah. When I have 73, do I need another bus? You're no, because it's a 72 passenger bus. Legally, you can only put 72 passengers in the bus. That's not a passenger. No, you guys. Okay. One of the things when it comes to mathematics, coming up with cute little exceptions that you think might apply don't work. The rules are 72 people on the bus, passengers on the bus. You have 73, you need another bus. That's the rules. And that's the way it goes. So every time that you have enough that meet the requirement, you jump up the next step. That's why you'll end up seeing a function that would look like this, a step function. Now, a discrete function, if you take a look at these down over here, those are just specific points. And that's the way it's always going to be. One thing in, one thing out. And it's always just going to be that. That's all it is. So if I want to graph the discrete continuous functions, what you need to do is get your graphing calculator here, and I'm going to show you a few things on how to deal with this. Okay? If we have discrete data and we want to go through and graph it and see what we've got, all we have to do, make sure you reset it, we press the stat key. We've used this before. We put the data in. We do edit, and for L1, anything that's on the X, we put it in. So we got 2, enter. Next one is 4, enter. Then we've got 6 and -1. Data's there. Now, press the stat key, edit, and then we can put 3 in for the Y, so we got the coordinate 2, 3, we've got 5, that goes in, 7, that goes in, and 0 goes in. Now, how do we display this? Once you've got the data put in, you end up pressing second, Y equals. So I press the second key, upper left-hand corner, Y equals, turn the plots on. We've done this before. Second, Y equals. Stat plot, so you're sitting here. If you press enter, it's flashing on the on. So you press enter again. Yeah, is it sitting on the on now and flashing? Okay, good. Then it's doing what it's supposed to do, as per the instructions that are on the whiteboard up front. Now if I press graph, I see the data. Yeah, there it goes. That's not continuous. Yeah, it's just discrete. It's just a discrete function. Yeah, you can just use a graph like graphing paper. Now, I will show you later on how to go and use the graphing calculator that's on your Chromebook so that you can copy and paste the graphs that are on it. Okay. Now, if we want to do B, we want to do a continuous function. No, that is in the form of a function, so it's g of x is equal to x plus 2. So I would press the y is equal, and I can put that function in there just simply as x plus 2. And if I graph it, then I see a line that comes across. Now we've done the graphing before. It's right there. Makes life a lot easier than trying to do it by hand. So, now, it wants us to state the domain and the range. Whenever we have a discrete function, the domain is always going to be x. So the domain here is going to be 2, 4, 6, and -1. That's what the domain is going to be. What about the range? Well, the range is always going to be y. So that means here it's going to be 3, 5, 7, and 0. What about if you have a continuous function? If you have a continuous function that is a line will always be domain, all reals, range, all reals. Will always be, yes, if you have to find the domain and the range of a continuous function that is a line, all reals, and range, all reals. Now, if you have something that is curve or something else, I'll explain how that goes. But for right now, this is what it's going to be. So, what about these? Now, a discontinuous line has a specific place where they're going to drop out. Now, the point of discontinuity is going to depend upon what type of a function that we've got. If I take a look at this over here, there is an open circle sitting right down here. That is the point of discontinuity. So if we were looking at this and saying, where's the point of discontinuity on this line? Well, that would be here at -1. So point of discontinuity is going to be right there. If I look at this graph here, now this function I happen to know is made by the equation f of x is equal to some number. I have no idea what it is, but it's going to be some number. I can put 1 over x. Okay? I know that this is what it's going to look like. If I have a function like this, what happens if you put 0 in for x? Well, you get division by 0, which you cannot do. So that means that the point of discontinuity here is where x is equal to 0. Here, it was where x was equal to 1. So whenever we're finding the point of discontinuity, you need to go and take a look at it where the gap is at, and always in terms of what x is equal to. Questions, guys? Bold question. So, identifying types of functions. So they want us to identify whether it's continuous, discontinuous, or discrete. If the function is discontinuous, we got to find where the gap is at. So if I take a look at 1, first offhand, continuous, discontinuous, or discrete? Continuous. Tells us that it continues on over here, so we've got one that's continuous. Is it, okay, so do I have to do anything else? No. So the next one, is it continuous, discontinuous, or discrete? Okay, so I got discontinuous here. Oops, let me spell better. Discontinuous. Where is it discontinuous at? Well, let's see. If I'm looking at this here, this is going, that's 4, so that's 2. That's kind of in the middle. I would say that x is equal to 3. Was that follow? Makes sense? X equal to 3. Okay. After all, it's counting by 2, so that would be 1, 2, 3, 4, so it's in the middle. Good enough. What is C? Okay, that is going to be the discrete, because it's just got points. Easy enough. Okay, did they ask for the range of domain? For which one are you looking at? The discontinuous one there in B? Then name the x values and where the discontinued happens to be. Oh, okay, I see what they're saying here. When they say they're naming the x values where it continues, would they have the point in here listed as 3, 2, don't they? Yeah. The reason why they have it listed as 3, 2 is because this is actually where the point is. This line here is on 2. Technically, according to what their question is, they are not identifying where it's at. Okay? 3, 2 is more information than what you need. X equal to 3, that's where the point of discontinuity is. Because technically 2 can't be part of it, so we don't necessarily think of it in those terms. They identify it as such, but x equal 3 is all that you need. So, here's the next question. Are they continuous, discontinuous, or discrete? And is the function a relation? And if it is, determine the domain of the range. So, let's go take a look at A here. Okay, so it's discontinuous. Is it a function? Remember, a function is if you put one thing in, you get one thing out. And remember, we talked about this, the vertical line test. Remember that one? We talked about this so that if you ever have a vertical line and you drag it and you run it through it, and it only hits it in one spot, it's a function. So did it hit it in more than one spot here? Nope. So that would end up being a function. So we've got this, that it is a function. Now, what does it mean to be a relation? What's the difference? You guys remember what the difference is between a function and a relation? Okay, you got the book open there. Does it say anything about what's the difference between a function and a relation? Okay. Well, you've got the book there. Does it say it's a function or a relation? For A, what does it say? Yep. So, it's a function because it's generated by an equation, not just specific points. So now we need to identify what its domain is and what its range is. So the domain. Now, I will tell you this much, it makes life a little bit easier than trying to identify where things are at. We would say for the domain, all reals, and then comma x cannot be equal to, where's the gap at? 2. And where's the other gap at? 5. All reals except x cannot be equal to 2 or 5. What about the range? Well, the range is on our y going up and down. Now, the last one we talked about this, I had a line sitting here, and the line kept going up and down. Now, I've got a bit of a problem because it only goes up so far, and it goes down. So, the range here is going to just identify where it goes across. Think of it like this. If you got a little stick dude, and you want to, I know, it's terrible. And I want to go through this way, okay? Can I get through here as I'm going up? The only place I can get through is once I get over this, right? Once I get over that, what value is that at? If I'm looking at going up and down, how far up do I have to go before I can get across it? 2, 3. So that means the range for this one is where y is less than or equal to 3. So the function is in all those places. Y is less than or equal to 3. Once I get above 3, I can get past it. Let's take a look at where B is at. So, continuous, discontinuous, or discrete. Okay? So we got a continuous. Now, function or a relation. Function. Okay? Domain. Now, does it have any gaps in it? No, no gaps, so that means that the domain here is going to be all reals. What about the range? Nope. Think about the little dude again. If the little dude is over here and he's trying to get underneath it, where does he have to go to get underneath it? Below what? 0. Where can't he go? He can't go where y is what? Well, yeah, it's equal to, but it's got to be greater than or equal to what value? 0. So the range on that one is going to be where y is greater than or equal to 0. What about c over here? Okay, so we got discrete now. Is it a function or a relation? Okay, when it's going to be discrete, then we got a relation going on. What is the domain? Well, since I've just got points, I got specific values for x. So the domain here is going to be at what? Well, -3, 0, 2, and 4. What is the range going to be? What's the range? 3. That's all I got to put, right? Because it's only at 3 here, 3 here, 3 here, 3 here. Does it change? Does it go anyplace else? The answer is no. So the range is just simply 3. So what I want you to do is I'm going to give you a little bit of time, and I want you to put those onto the graphing calculator. So we take a look at this on the graph again. Again, you can go to second plus 712. If you reset it, it also turns off the stat plots. So you can go back in if you want to do that right away and turn the stat plots back on so that it's there. So now when I go to stat, edit, put the information, 0, enter, 2, enter, yeah, I know, -4, enter, 9, enter, got those in there. So then I put in 0 again, I got 3, 6, and 10. Make sure that you have the data going across, that these points match up with what you got. Now when I go through and graph it, I end up seeing the points there. Okay. You don't really see the 0 because it's at the intersection of the lines. And you'll notice that this one's kind of broke off a little bit up here because that's at the edge of the window. Now if I put the other equation in here, that's x equal to 5. I just put a 5 in there and I graph, and all that's going to do is draw a line straight across. So now, our domain and range of the discrete function. Domain is going to be all of our x coordinates, the 0, the 2, the -4, and the 9. The range, 0, the 3, the 6, and the 10. Now, the domain and range of this one. For this function, the domain is going to be all reals again. Why? Because the graph goes across and keeps on going. What is the range going to be? Well, think of the little dude again. He can go over 5, he can go under at 5, but he can't go at 5. So that means that the range for this one is just 5. So how you could see that written down would be domain would be all reals, and range y is equal to 5. That's it. Okay. So if I take a look at this one, what is this going to be? Continuous, discontinuous, or discrete? You sure? Okay. Is there a hole in the darn thing? Yeah, we got to end up having a hole sitting right here. So that's going to be discontinuous. So we know that's the case right now. We've got discontinuous. So where is the discontinuity at? Well, the discontinuity is at x is equal to 4. Now, the book may give you the answer as 4, 5. Okay? The reason that they would give you that answer at 4, 5 is because it looks like that point is halfway between here and there. And they're counting by 4s, or actually they're counting by 2s, so halfway between 4 and 6 is 5. Do I know that it's there? No. Do I know what the function is? No. So this piece of information here is really all that I need. Again, that's why I disagree with the textbook in this case, saying that it's at 4 comma 5. I don't really know that. So, what about this one? Who thinks they've got this one? Knows exactly what it's going to be. You do? What's it going to be? Where is it discontinuous at? Up right here? Okay, so you say that there's a gap there someplace. So then it's got to be continuous. I don't see no gap there. Does anybody see a gap in there? So, there we go. That's all we got to do because it's continuous. You don't have to, there is no point of discontinuity. So Bailey, we're going to go for redemption now. So which one is this? Continuous, discontinuous, or discrete? Okay, so you got discrete. Okay, do I have to do anything else? Nope, that's all I got to do. So, Cole, what do I got? Continuous, discrete, or discontinuous? Got continuous. Okay, so let's go this way. This Lindholm, what's the range here going to be? Actually, I should probably ask this question first. Is it a function? Absolutely correct. Not function. No. Reason why. Okay, remember when we said we talked about this horizontal line test? If I go and drag a horizontal line through this, how many places is it hitting the graph right there? 2. No, that's the vertical line test, and that tests forward inverse. So, this does not pass the vertical line test. It is not a function. Now, we can go and still state that the domain on this particular relation, or however you want to go and identify it, is going to be from x greater than or equal to 0. The range would be all reals. I mean, it doesn't, again, it doesn't look like it, but it's going up here and it's going down here. So eventually this thing would continue through and get everything. But it's not a function. So in this case, they would go and identify this as a relation. There is a relation there, but it's not a function. So, now, is this discontinuous, continuous, or discrete? No. What do you think? Continuous, discontinuous, or discrete? Discontinuous, okay. We can live with that. Is it a function? Yes or yes, no? Well, yeah, technically he's right. I mean, it's yes or no is going to be there. Okay, so okay. If I go and use my line again, if I go through this, how many places does it look like it's hitting? Now, when we get to here, it looks like it's hitting it in 2 places, right? But this is a closed circle, which means 2 is part of this one. This is an open circle, which means it's really, 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 really close to 2, but not quite. Okay? Yeah, really close. You know, it's that whole I'm not touching you idea. You know, your finger gets really close, but so is this a function? Yes, this is a function. Yeah. You started off being right, you second test yourself. Okay. So, what is the domain? Well, the domain goes from here all the way over to here. Now, how I would write this domain? It starts off at 0, less than or equal to x, less than 4. Why? Closed circle here, 0 is included. Open circle over here, 4 is not included. Range. range is going to be 0 and 2. Okay? Because it's here at 0 and here at 2. So, what do we got, Kitty? Continuous, discontinuous, or discrete? Discrete. So, is it a function? Yes. Okay, so we'll go with function. What's the domain of the range? Okay, so what's the domain going to be here? Get the right color, I guess. So, what's the domain going to be, Micah? Okay, the domain. A little dude is going to be down here. Okay, he's looking up. Where does he see things? Well, yeah, he sees things on the up. Of course he does. So if he's over here, where does he see this? Where does he see that point? So where does he see that point? If he's trying to go up, where does he see it? No. Where does he see it? -2. Why was somebody saying 5? Oh, I'm sorry. What's going to be here? What's he going to see here? 0, yes. What's he going to see over here? 1. What's it going to be here? 6. Okay. So now he turns around. He's going this way. So we'll get him over. Uh-oh, he lost his leg. I broke his leg. I'm sorry. You know what? We're just going to make a whole new person over here. I'm going to just, yeah, I just got to make a whole new person. So he's going this way. Where is it going to be for this one? 0. This one here. Yes, go west. What's that one? 3. What's this one? 5. And what's this one? 7. That's it. That's how you find it. Yeah, that's how those little dots are. Now, the nice thing is, if you were to go actually take a look at this, what's the coordinates here? Well, that's 0, 0. This coordinate here is going to be -1, 5. This one over here is going to be 1, 3. And this one over here, oh, -2. Quiet. It's because I missed. This one's going to be 6, 7. So, if I were to go and take a look at this, -2 is here, 0 is here, 1 is here, 6 is there. It's all our domains. Our ranges. I've got a 5, which is right there. I got a 3, which is right there. I got a 0, which is right there. And I got a 7. So that's where they come from. Domains are your x's, ranges are your y's. So, we're going to call it quits there.